Now example 2.8. A slab of material of dielectric constant K has the same area as the plates of a parallel plate capacitor, but has a thickness 3 by 4D, where D is the separation of the plates. How is the capacitance changed when the slab is inserted between the plates? Now see here, in theory we studied this thing when the dielectric substance is introduced between two plates of the capacitor. At that time the capacitance is increased by K times. But in that particular case we considered the entire space between two plates is filled with dielectric substance. Here the thickness of the dielectric, that is 3/4 D, and separation between two plates, that is D. So we can say in some part of this particular space between two plates of the capacitor, the dielectric substance is introduced. So first understand the situation. Say here, this separation is D, and the dielectric substance introduced here, that is with thickness 3D by 4. So when dielectric substance is not there at that time, the electric field between two plates of the capacitor, means when there is the vacuum, electric field is E0. So now the portion in which there is no dielectric substance, there the electric field will remain same one, E0. In the region where the dielectric substance is there, inside it the resultant field, that is 1 upon K times, so E equal to E0 by K. Suppose here in this portion with thickness D by 4, where there is the vacuum, the potential difference is V1, and inside the dielectric slab there is the potential difference equal to V2. This portion is D by 4, this portion is 3D by 4. Clear? Now see here, we can write here V0, that is equal to E0 into D. So here the resultant potential difference between these two plates of the capacitor, that we can write V1 plus V2. Now here V1, as per this equation we can write electric field into this particular separation. Here also potential difference, that is electric field into this particular separation. Now V0, that is equal to E0 is sigma upon epsilon 0 into D sigma, that is Q0 by A. So here capacitance C0, that is epsilon 0 A by D, and that is Q0 upon V0. All these things we already discussed, that is just mentioned here. Okay. Now when the dielectric slab is inserted, the potential difference V, that is V1 plus V2. So we can write V, that is V1, electric field in this region, that is E0, into this particular distance, that is D by 4, so that is V1. For this V2, that is electric field E0 by K, this particular distance, that is 3D by 4. So now we can take E0 D by 4 common, so we can write 1 plus 3 by K here. Clear up to this one? So here we can write E0 into D, that is V0. So V0 by 4, take here K LCM, so K plus 3 by K. Now C, that is Q0 by V. So here we can write C, that is equal to Q0 by V. V, that is V0 by 4 into K plus 3 by K. So we can write here V, that is equal to this one. So directly if we substitute, then 4K upon K plus 3 into V0. So here Q0 upon V0, that is our original capacitance. So we can write C, that is equal to 4K upon K plus 3 into C0. It implies that if the dielectric slab having dielectric constant K and thickness 3/4D is introduced between two plates of the capacitor where the separation is D, the capacitance that becomes 4K upon K plus 3 times the original capacitance. Clear?